In our previous video, we talked about operators and precedence in C programming language. In this video, we are going to be talking about looping in the C programming language. First of all, what is a loop? Well, a loop, you can think of it as the repetition of a given task. C programming offers us a few ways of looping over statements or blocks of statements. In this video, we are going to be looking at the for loop. The for loop has the following syntax. We have a for keyword followed by an opening parenthesis, and then an expression 1 followed by a semicolon, another expression 2, a semicolon, expression 3, and then a closing parenthesis. And then from there we have a body for the for loop, and this body is demarcated by curly braces. Whatever is within this body will be evaluated, or it will be ran as long as expression 2, which is known as the test condition, is true. So meaning that the number of times this body will be ran depends on the initial condition, expression 1, and whether the test condition is true. Let us have a look at how the for loop works. Step 1 is the initialization. Step 2 is the evaluation of the test condition. If the test condition is true, we shall go to step 3, and that is running the body of the for loop. After running the body of the for loop, we shall go ahead to update the initial expression. After updating the initial expression, we shall go ahead to test the test condition again. And if the test condition is true, we shall run the body of the for loop again. And like this, we shall continuously run the body of the for loop until a point where the test condition does not satisfy anymore. Let us have a look at the code. Let's begin by declaring an integer variable I. Like we've seen from our previous picture, we've seen that the for loop begins with the for keyword followed by an opening parenthesis, and then we also have a body. Inside the parenthesis we have the initial condition, and our initial condition here is I equal to 0. Okay, let's say we want to print numbers from 1 to 10. So here we shall make I 1 because we want to print from 1 to 10. And then we shall say as long as I is less than 11, I is equal to I plus 1. So what we shall do inside here is to write a printf statement. Of course, the printf statement, what we'll do, it is to print out whatever we give to it. The first argument is a string, and we're going to say that the value of I, and then we say that we're expecting an integer, and then put I here. We can also write a new line character such that the output looks a little bit spaced. When we build and run this, we get this beautiful output. The value of I is 1, and like this we go until the value of I is 10. To go over again this code, we start by initializing I to 1, and then check if I is less than 11. If I is less than 11, we shall run this printf statement, and what we are actually doing is simply saying that the value of I is, and then we print out whatever the current value of I is. After that, we go ahead to update the initial expression. How do you update it? For our case, we are saying that now whatever I is previously, add it a value 1. If we began with I equals 1, after the evaluation of this expression the first time, I will be 2. And like this continuously, we go on incrementing the value of I. At every time on the increment of the value I, we check if I is still less than 11. And the moment I is still less than 11, we run this one again. And we shall run this line of code until a point whereby I is equal to 11. Now let's say that we have just printed this statement that the value of I is 10. So it means that the current value of I is 10. If you add 1 to 10, you get 11. Now 11 less than 11, of course that statement is false. And since that statement is false, this will result into terminating of this for loop. That's why our program stops running the moment I is 10. We can also count from 10 going downwards. Now for this case, since we're starting from 10, we want to count from 10 until 1. So we shall make sure that as long as I is greater than 0, print whatever is inside here, and then after printing it, reduce the value of I by 1. When we run this, we see that now we begin from I is 10, and then we go decreasing until the value 1. Well, now we've been running this code, and we've been incrementing or decreasing the value of I by 1. How about taking a bigger step? Let's say incrementing it by 5 or reducing it by 5. It's all possible. When you look at this code, if you want to achieve let's say an increment of 2 other than 1, we shall simply remove 1 and place 2. This means that we shall be reducing by a step of 2 instead of a step of 1. When we run this, you see that we begin by 10, reduce by 2, reduce by 2 until a point 2. Great. We are doing so good so far. Well, there is also another form of for loop, which is the nested for loop, and that is having a for loop inside another for loop. Now, for example, on top of this for loop we are having currently, we can have another for loop, or maybe inside it we can have another for loop. And how would we do that? We simply come inside here and write another for loop. However, we shall also have to declare another variable j, which we are going to use for our initial expression, and let us give it a value 5 instead, and let us say that j, as long as j is greater than 0. In the outer loop we shall be counting from 10 to 2, and then in the inner loop let us count from 5 to 0, right? Or maybe from 5 to 1. So what we shall be doing is let us simply reduce j by a value 1. And we shall also go ahead to print out the value of j. The value of j is j. When we run this code, to make it look more clear, alright, let us first run it. Well, this is how it looks like, but we cannot look so clearly to see the difference. How about if we begin by printing something here? Let's say printf. Let us print a few hash characters and then a space. Of course, don't forget the semicolon. Run this. And maybe it looks a little bit better than before. So we begin by printing these hash symbols, and then so the value of I is 10. Now the first time the value of I is 10, and then we print j from 5, 4, 3, 2, 1. After that, the inner for loop will stop running, and then we shall go back to the outer for loop. This time around, since originally I was 10, reduce it by 2, we shall get an 8, and then after reducing it by 2 we get an 8, and still an 8. Since an 8 is still greater than 0, we shall go ahead to evaluate the body of the inner for loop. In the inner for loop, we print 2 statements, and then we have another for loop which also has its own body, and this body runs 5 times because we initialize j to 5, and as long as j is greater than 0 we print this statement, and then after that we reduce the value of j by 1. There is a very important application of a nested for loop. For example, let us have a look at a multiplication table. This is how a multiplication table looks like. Can you think of a way we can realize a multiplication table using a nested for loop? We can actually realize this multiplication table using a nested for loop. And how can we do it? Well, when you look at this, realize that first of all we maintain the value on the left constant and only change the value on the right, meaning that we can make this value to be the outer for loop, and then we run the inner for loop this number of times, which are 10 times, and then each time we get the product of the value of the outer for loop and the value of the inner for loop, and like this we can print out a table. Let us test it. Let us print out this table using our for loop. It has modified our code a little bit so that we can print out a multiplication table. We can take out this printf statement and put it outside here and say multiplication table. What we're going to do here, from what we've seen previously, I begins at a value 1 and then it goes up to a value 10. So we shall say as long as less or equal to 10, and then it increments by 1. There's also another shorthand way of saying I plus 1. Simply writing 2 plus sign is equivalent to saying that I is equal to I plus 1. And then after that, we may not need this printf statement, so we shall delete it. Inside here, we shall also need to have we shall also need to loop 10 times. We shall also declare this to 1. We shall give it a value 1, and then as long as it's less or equal to 10, run the code inside there, and then after that increment its value by 1. So what are you gonna print out inside here? Inside here we can say that first of all we have one digit multiplied by another digit equals to another digit. So we can give in these digits. The first one is the I, the value in the outer loop, and then j, the value in the inner loop, and then the last value is the product of these two values. Let us print a new line such that they look a little bit spaced. When we run this code, this is what we get, but it looks so cluttered. How can you make it look better? We can see that this is a multiplication for 1 and then multiplication for 2, so you can maybe create a space in between here by printing a new line character. Run this again, have a look. Oh yes, okay, this one looks pretty more spaced. But also these equal signs, they don't seem to be in line. How can we put them in line? Alright, we can modify the output of the printf by saying that let this value occupy 2 places, and let also this value occupy 2 places. When we run this, okay, this one looks better than what we had before. Okay, from this code we have realized a multiplication table using a nested for loop. You can get this code from our GitHub project. The link is in the description box. If you've not subscribed, please subscribe and leave a comment in the comment section. See you in the next video. Thanks for watching.